Hello everybody. Today I'll be attempting this question from the Edexcel GCSE 2022. This was the final question on a non-calculator paper and it involves finding the area of a shaded region, 3 circles. Okay, let's go through the question. The diagram is made of 3 circles, each of radius 4 centimeters. The center of the circles are A, B, and C, such that ABC is a straight line. Work out the total area of the 2 shaded regions. Give your answer in terms of pi. Okay, so my first thought when I saw this question was to calculate the area for these 2 regions and then take that away from this large circle, which is definitely doable and works in a very similar way or the preferred method, but it's just a little bit more inefficient, as you'll see later. But it would involve finding the area of this, which is, I guess, the difficult part of this problem, and as would the preferred solution, except, it involves less steps. Okay, so immediately, this is the part that gives us trouble. So we can draw a triangle here, and then we can also draw a sector. So if we label this S, you can see that it is the area of the sector minus the area of the triangle. And then this is equal to S and this is equal to S. Why? Well, this is 4 centimeters, this is 4 centimeters. And draw a couple more triangles. Okay, now these all have lengths 4. So this is an equilateral triangle, this is an equilateral triangle. Therefore, this is an equilateral triangle, as the angles on a straight line add up to 180. Okay, now why is this region S, this region is S, and this region is S? So why are these 3 regions S? Well, it's because we have 3 triangles, and these are each congruent by SAS, so side angle side. Therefore, since these circles are the exact same as well, S must be the same each time. Okay, so how do we actually calculate S? First of all, we need to calculate the area of the sector. Okay, so the formula for the area of a sector is pi r squared theta over 360. Theta equals 60 degrees, as we found out before. So pi 4 times 360 simplifies down to 8 pi times 16 pi times 1/6, which is equal to 16 pi over 6. Okay, that's good. Now we need the area of the triangle. This is slightly harder. So we know the angle is 60, so therefore we can use the formula half times AB sine C equals area. So we can sub our values in. Half 4 times sine 60. This is just 8 times sine 60. And the thing is, it's a non-calculator paper, so you must memorize your trigonometric values. You can use the triangle method if you want, but I think it's easier to just memorize them. Well, obviously understand the triangle method as well. Okay, anyway. Sine 60 is root 3 over 2. So therefore, this simplifies down to 4 root 3. Okay. So S is equal to area of sector minus area of triangle. So we can sub our values in. We've got 16 pi over 6 minus 4 root 3, which can also be written as 16 pi minus 24 root 3 over 6. All right. Now, what does S actually tell us? Like, how is this going to help us with the problem? Well, we found out before that let's just get rid of the infinite. We're not using it. Okay. So this S is equal to that S. Therefore, we can calculate, well, one of the shaded regions by getting the area of the sector, which we already have, and then minusing S twice, because we already know S, and all these three sections are equal. Okay. To shaded region. Okay, so obviously we've got 2. So we can just multiply this expression by 2 to not forget doing it later. Okay. Area of sector, 16 pi over 6 minus 2s, which is 32 pi minus 48 root 3 over 6. Now, this can also be written as, well, minus 16 pi plus 48 root 3 all over 6, which is also minus 16 pi plus 48 3 all over 3, which is therefore 16 root 3 minus 16 pi. This is our answer. Well, thank you for watching, everyone, and I hope you learned something. Goodbye.